This is the fourth day of systems of linear equations. You know what? We might as well just go all the way back in the beginning. Let's just do a very, very small type of summary. Systems, two or more equations. There's an x and there's a y. The first part that we did was solve by graphing. If the lines intersect, then we are going to write our solution as x comma y. Sometimes, though, our equations are not in slope-intercept form. So let's go ahead and take a look at this pink equation over here on number 5. We have to solve for y. How to do that? You're going to move all the x's over on one side. So we add 6x on both sides. As a small reminder, these two are not like terms. So you're just going to write this as 6x plus 12. Divide both sides by -3. And it will be back into slope-intercept form. Sometimes their lines don't intersect. So you say no solution as your solution. Sometimes your line is the same line and that's infinite solution. And just like the last couple classes, number 8 is a really good summary of what you should be writing in terms of those 3 different scenarios. Okay. The second class, we did substitution. Substitution means to plug in. On number 21, you have big scenario number 1. Maybe both of them are y equals. When both of them are y equals, you're going to set it up like this, y equals y. The left equation will be on the left expression. The right equation will be on the right side. Once you have one of the values, you're going to plug this in into any of these equations to get the second value. Just be careful. Sometimes one of the equations is solved for, and so if it says y equals, you're going to plug that in into the y in the standard form. If it says x equals, you're going to plug that into the x and solve. Please be careful with your special cases. Sometimes you'll have mathematical statements. If it is a false mathematical statement, no solution. They're probably parallel lines. If all the variables cross out and you have a true mathematical statement, it is infinite solutions. They are the same line. Last class, we did elimination. The first one was add down first. The reason why elimination works, like on number 33, is because one is positive and one is negative. Positive 2, negative 2. That's why those variables get eliminated, hence the word elimination. Add down, once you solve for one, then it's similar to substitution. You can plug it back into any of the equations. All the special cases come out to play as well. If it's false, no solution. The biggest one that we had was number 39 with all of these. Sometimes your equations don't add down normally and no variables get eliminated. So you might have to multiply one of the variables by -1. Or in last class, number 43, we could target any variable that we want, but we just have to make sure that we multiply each row by that multiplication that we asked for. So again, what we said was 3 times what makes it 12? We said 4. So we're going to multiply 4 all on the first row. 4 times what makes a -12? We multiplied everything by -3. And then we can add down. On today's lesson, we're going to use this technique to do the word problems. Let's go ahead and do that. 51 right now. Trevon and Natalie are selling pies for a school fundraiser. Customers can buy apple pies and blackberry pies. Trevon sold 4 apple pies and 14 blackberry pies for a total of $324. Natalie sold 4 apple pies and 4 blackberry pies for a total of $124. What is the cost of each 1 apple pie and 1 blackberry pie? Okay, since I've read the problem for you, this is the 4 steps that you guys can do to solve this. Number 1 on number 51 is set your variables. Because we're used to using x's and y's, we can go ahead and use x and y. After a while, you get a little bit comfortable. Maybe you can use maybe A or B, or C or D, or whatever it says, you know, A for apple, B for blackberry. But for right now, we can just use x and y. We don't have to stray away from what we already know. We're going to set them in words so that we know what we're trying to solve for. And it's based on the last sentence. What is the cost of each 1 apple pie and 1 blackberry pie? And so maybe we can say x is the cost of the apple pie, one of them, And y could be the cost of the BlackBerry pie. The reason why we want to set our variables is because when we have the numbers at the end, we can write one sentence to say, okay, the cost is this and the cost is this, and we will match it up accordingly. Any questions on step number 1, setting the variables? If there are no questions, step number 2, you are going to create the equations, and you're going to create them very similarly to last class in standard form. Create equations in standard form. This sounds intimidating, but the sentences that provided for us will actually be like a literal translation of how the equations are, what we're going to write the equations. So I want to start on that third sentence that says Trevon sold 4 apple pies. Here, let me repeat it again. Trevon sold 4 apple pies and 14 BlackBerry pies for a total of $324. So I'm just going to go word by word. 4. And then we don't know the cost of the apple pies, so that's going to be x. And is a plus. Then we got 14. 14 BlackBerry pies. Well, we don't know the cost, so we're just going to put y, 14y. Equals what, you guys? 324. So hopefully you guys can see that the sentence kind of already gives you the structure of the equation. Okay, so 4 apple pies and 14 BlackBerry pies equals total 324. Okay, so with that said, on the 4th sentence, starting with Natalie, you guys tell me what to write for your second equation. Ready? Go. 4x plus 4y equals 124. Nice. Okay. So based on the 4th sentence that starts with Natalie, Natalie sold 4 apple pies, 4x, plus 4 BlackBerry pies, 4y. Total equals 124. Once you have these 2 equations in standard form, you are going to do the same technique as number 45 and 46, which we will also do together right now. Okay, let's go ahead and take a look. I'm going to tell you guys that looking at the x's, I think the x's might be a little bit easier to target, okay, because they're almost opposites. Let's go put our target ideals. One needs to be positive 4, and the other one needs to be negative 4x. So we're just doing target ideals. We're doing target ideals so that we can do elimination properly when we add down. Take a look at your first row. Are there any changes on this first equation, 4 and 4? No changes, so we're going to leave that. Take a look at your second equation, though. What are you going to multiply 4 by to make it negative 4? Negative 1. Okay. So just like last class, you're going to multiply negative 1 to each of these 3 terms. When you multiply by negative 1, just like in that last class, you're just changing every single sign. Okay, apology that I don't have room, so I'm just going to bring it up over here. Okay, you guys told me that the first equation, there's no change, so we will not change the first equation. 4x plus 14y equals 324. Okay. Second equation, though, let's go ahead and do that. Negative 4x minus 4y equals negative 124. I think we can safely add down now. Because if we add down now, which variable gets eliminated? The x's. 4 minus 4, that's 0. So you don't have to write 0x anymore. Okay, what is 14 minus 4? Or 14 plus negative 4? 10y. Then what is 324 minus 124? 300 or 200? 200, thank you. Okay. Divide both sides by 10. Y equals 20. And we'll take notice of that. Tell me what to do with the 20 now. We're going to plug it in into any one of our equations that we just made. I usually plug it in on the first. It doesn't matter. You can also plug it in on the second. So step number 3, I'm going to plug in 20 where the y is at. So I'm just using the first equation. And I'm going to plug in the 20 over here. Just like last class, I do want to remind you guys, some of the mistakes I see is some students plug in the 20 in the x. Please be careful where you plug things in. It says y equals, you plug it in the y. You solve for x equals, you plug it in the x. Please be careful with that. I need help. 14 times 20? Thank you. 280 equals 324. What are you going to do on both sides now? Subtract 280 on both sides. I'm running out of room, so let me just move it up over here. 324 minus 280. Thank you. And we're going to nicely divide by 4. X equals 11, and we'll take notice of this. On your final step, step number 4. So usually you would write this as 11, 20, and you could if you want. We need to write one sentence, and one sentence only, to answer the question, what is the cost of each one apple pie and one blackberry pie? Well, we can say, since X is the cost of the apple pie, we can say apple pies cost $11 each, and blackberry pies cost $20 each. Is that pretty expensive? I don't know. Is that expensive to you guys? $11 for an apple pie? I think so too, yeah. It's pretty. I think even the commentary is way cheaper. Okay. So, apple pies. Let me just zoom in. Cost $11 each. One sentence should suffice. Please no intro, body, and conclusion like a speech class. You just one sentence, please, okay? Apple pies cost $11. Blackberry pies cost $20. Okay? Don't make a speech about this, yeah. Have you ever tried apple pies? Sorry, because I know some people are here in my speech class. Have you tried blackberry pies? Well, today, they cost $11. No, don't do any of that, okay? No self-expression. You just write the sentence like that. That's it. Okay. Any questions on 51? Any questions? Oh, boy. Okay. Last one. And then afterwards, the rest of the time will be yours to finish all of this, and along with your toolkits, okay? Sorry, I didn't even ask. Were there any questions on the 4-step process to solve this? 4 steps. Okay, we can probably go a little bit faster on 52. The water park is a popular field trip destination. All right. This year, the senior class at high school A and senior class at high school B both planned trips there. Nice. The senior class at high school A rented and filled 14 vans and 10 buses with 16 students. High school B rented and filled 6 vans and 11 buses with 656 students. Every van had the same number of students in it as did the buses. How many students can a van carry? How many students can a bus carry? Okay. I don't know why we're doing algebra with this. Why can't we just take a van and just count the number of seats a van has? Okay. Anyway. All right. So, sometimes, I don't know, algebra makes things a little bit harder, and sometimes algebra makes things easier. You know what? Let's just go ahead. Yeah. It would just be easier if you just grab a van. Give me the van. How many seats are in there? Okay, that's nice. All right. But because this is just practice for elimination, let's go ahead and practice this. Again, if you feel comfortable, you can use V and B for your variables. that's totally fine. But if you don't, x and y is okay. Since the question is asking how many students can a van carry and how many students can a bus carry, let's set x for the number of students in a van. Like how many students can fit in one van? Students in a van. And then y, students in a bus. And now let's make a speech. Have you been in a van? Have you been in a bus? Well, you can do both. Okay. I think we can make our equation starting with which sentence? The first, second. We can start it with the third sentence over here. High school A with this. Okay. We already just read it. You tell me what to write on your first equation based on high school A. Ready, go. 14 what? 14x. 10y equals 716. Nice, yeah. So based on that sentence. Now, based on the sentence of high school B, you guys tell me what to write. Ready, go. 656. Nice, yeah. Okay. So again, those sentences is kind of almost like a literal copy of what they're trying to just tell you the equation right over here. Okay. Sometimes, though, we might have to multiply both of the equations. Because we targeted x on number 51, let's go ahead and target y. Again, it doesn't matter what you target. We can target anyone we want. Okay. One of the easier ways to do this is just grab a calculator. If you're not too good with your multiplication, just go 10 times 11. Well, some of you guys already know it by your head. What is 10 times 11, you guys? 110, okay? But remember, for our target ideals, one needs to be positive 110, and the other one needs to be negative 110. So write your ideals. One needs to be positive, the other one needs to be negative. Again, how I got 110? 10 times 11. When we do it in this method, some of your numbers are going to get huge. We're going to get into the thousands, and that's okay. Let's take a look at the first equation. Students, what are you going to multiply 10 by to make it 110? 11, yes. We're going to multiply everything by 11 on the first equation. And we'll do that a little bit later. On the second equation, be careful. What are you going to multiply 11 by to make it negative 110? 10 or negative 10? Negative 10. So yes, your numbers are going to get huge. But I mean, you got your calculators. So let's go ahead and use them. Okay, let's do the first equation. You multiplied 11 on every single row on the top. So what's your new first equation? 154x 110y equals, and then I need 11 times 716. What is that? Okay, can someone check this? Where you're multiplying 11 on this. Did you guys get the same thing? 11 times 14, 11 times 10, 11 times 716. Okay. Okay. Thank you, thank you. All right, now we multiply negative 10 on the bottom row. So what's your new equation? Go ahead. Thank you. Thank you. Negative 7,216. Okay. I always need people to double check. Please double check right now. Everyone agree with this?
Yes.
Okay, all right. Now let's go ahead and add down. It's not? Where? Where? Second equation. Oh, you mean this one over here? Oh, yeah, that. Okay, yeah. This is why we need all of you guys. We need all. I'm gonna let you know, a lot of the mistakes, like, it's because of the multiplication and the addition. Like, it's really hard to check your work, like where to. Okay, I hope it works. Let's just hope, because I'm scared if we make a mistake, you know. Like, what if we get a decimal answer? I'm like, oh, we gotta go back. Okay, which variable gets eliminated? The x's or the y's? The y's are gone. Okay, I need help. 154 minus 60. 94x. Yeah, I need your help. 7876 minus 6560. Sorry. 1000? Thank you. Okay. This scares me. Okay. I hope it works, you guys. I'm so scared. Can someone divide this by 94? It's 14? Okay. Nice. Okay. I was afraid that, you know, like if it was like 14.765, I'm like, something's wrong. Okay, good. We're going to take notice of that a little bit. I'm always using the first equation. Let's go ahead and just use the second equation, and we're going to plug that in. Again, please be careful. Because we solve for x first, you got to plug that into x equals. Okay, please be careful. 6 times 14. 4, 2. Thank you. Okay. And then we're going to subtract what on both sides? We'll subtract 84 on both sides. 572, thank you. Okay, so 11y equals 572. I hope this works out. Divide by 11. 52. Okay. To finalize this, we are just going to write one sentence, and so this just go back to the x. 14 what? And we go back to the variables that we set. 14 students in a van, and then 52 students in a bus. So one way you could write this, a van holds 14 students, and a bus holds 52 students, period, or any English equivalent that says something about the van with 14 and a bus with 52. Oh yeah, I guess I lied to you guys. Sheesh, that was 24 minutes of teaching. That was a long time. Okay. But that is it for me. You will now do 53, 54, and 55 on your own. If there were some problems that you didn't do, please go ahead and also do that too as well. When you're totally done, please do your toolkits. And when you're totally done, there might be a small puzzle I'll ask you to do. Okay, that's it for me. I'll help you do, I'll just do 53 silently for you guys.
Okay, if you're still a little bit confused, 53 has been set up mostly for you.